traces vectors in under 4 minutes. A scalar is a quantity that has magnitude but no direction, whereas a vector is a quantity that has both magnitude and direction. Examples of scalars are distance, speed, temperature. Examples of vectors are displacement, velocity, and acceleration. When adding two parallel vectors together, for example v1 and v2, all you do is add the two magnitudes of the vectors together. So your resultant vector, or your overall vector, would be v1 plus v2. For example, if your two vectors are velocities of 7 meters per second and 12 meters per second to the right, you just add 7 meters to 12 to give you 19 meters per second to the right. Now, if your two vectors are acting in opposite directions, then you have to subtract the two magnitudes together, which gives you v1 minus v2 in this case. So for example, if our vectors were forces acting 17 newtons to the right and 31 newtons to the left, you subtract 31 from 17 to get you 14 newtons to the left. Now, if vectors v1 and v2 were perpendicular to each other and you wanted to work out the resultant force, you would move v1 so the two vectors are tip to toe. You can then add a line to turn this into a right angled triangle. The longest line of this triangle, or the hypotenuse, can be used to represent the resultant force. As this is a right angled triangle, you can use Pythagoras theorem to work out the size of the hypotenuse, or the magnitude of the resultant force in this case. The direction of the vector is given by the angle within the right angled triangle, which we can call theta, and we can work this out using trigonometry. v1 is opposite to theta, whereas v2 is adjacent to theta. So by using SOHCAHTOA, we can identify that tan is what we need to use to work out the value of theta. So as tan is opposite over adjacent, we can say that tan theta is equal to v1 over v2, meaning if you want to find out theta, you need to do tan inverse of v1 over v2. So let's say our two vectors are forces of 12 newtons and 21 newtons. First thing we do is move the 12 newtons to make it tip to toe, and we can draw the hypotenuse to represent the resultant force. Using Pythagoras theorem, we can say that 12 squared plus 21 squared is equal to r squared, and if we square root that, we get an answer of 24.19 newtons. To find the direction of the force, or the angle theta, we can use SOHCAHTOA again, and by using opposite over adjacent, we can say that tan theta is equal to 12 over 21, and to find theta, we can do tan inverse of that, which gives us an answer of 29.7 degrees. And by looking at this diagram, you can tell that this angle is to the horizontal. Resolving a vector is when you get a vector with a known magnitude and direction, and you split it up into two components, its horizontal component, vx, and its vertical component, vy. As this also forms a right angled triangle, you can use trigonometry to work out vx and vy. For the horizontal component, we can use cos theta, as we know cos is adjacent over hypotenuse, or in this case, vx over v. Rearranging this gives us the expression for working out the horizontal component of a vector as vx is equal to v cos theta. Similar thing can be used to work out the vertical component of a vector, vy, but by this time using sine theta. And as sine theta is equal to opposite over adjacent, we can say it's equal to vy over v. This means that vertical component vy is v sine theta. So let's say we have a vector v traveling at 9 meters per second at 23 degrees to the horizontal. We can draw a horizontal and vertical line to represent the horizontal and vertical component. To work out the horizontal component, we're dealing with the adjacent and the hypotenuse of the 23 degrees, so we use cos. So cos 23 is equal to vx over 9, and we can rearrange that to find vx as 9 cos 23. This gives 8.28 meters per second. For the vertical component vy, we're going to use sine as we're dealing with opposite and hypotenuse, which gives us vy over 9, and we can rearrange that to make it vy is equal to 9 sine 23, and that gives an answer of 3.52 meters per second. This was obviously a very quick summary. For a longer, more detailed explanation of the topic, check out the link to the full lesson and subscribe to my channel.